In this video, we're going to look at quadratic functions and their graphs. So we're going to look at characteristics of quadratic functions, and then we're also going to graph them by hand. So just some pieces of information. I know this can be overwhelming, but if you just look at the blue quadratic graph, you also might have heard this referred to as a parabola, okay, a U-shaped graph. Different ways to call it. We're going to call it quadratic or refer to it as quadratics for this unit. We have some kind of key pieces of information for quadratics that we always want to look at. So the vertex for this one is our minimum point, okay? So this is that lowest point, and again, it's the center and the lowest, okay? So it is that kind of vertex point. It is also from there our quadratic faces up, okay? So we go from that point facing up. And then we also have our axis of symmetry that runs through our vertex, okay? So our axis of symmetry cuts our graph in half, okay? And anything that is on the left is then reflected onto the right side. So for example, if we look at, let's say this, let me find a good point. This point right here, okay? So notice this coordinate we could say is at -11 and it's up 1, 2, 3, okay? Notice that same point is reflected across at 1, 3, okay? The thing that is special about this, and I'm gonna move this up so I can draw a line, is the distance from the point to the axis of symmetry, okay, from the left and from the right is the same, okay? So these are at the same y value, okay? This distance from the axis of symmetry is the same distance, okay? And that distance is, let's see, 1, 2, 3, 4, 5, 6. Okay, so that distance from that point on either side is 6. So that's what our axis of symmetry is doing, okay? And we can use it to kind of think about how our points reflect from one side of the graph onto the other side, okay? So that's a little bit about the axis of symmetry, okay? We also have x and y intercepts. Okay, we've talked about these before. We actually solved for x-intercepts of quadratics way back. I think it was like week 4. We solved by factoring. We solved using square roots and the quadratic formula. So we found the x-intercepts of quadratics before. We haven't specifically talked about y-intercepts of them before, but we've talked about y-intercepts of, linear functions. Okay, same idea. The y-intercept is where we cross the y-axis. X-intercepts are where we cross the x-axis. Okay, if you look over at the green, okay, graph, it's the same as the blue one in terms of terminology. The axis of symmetry is cutting that in the middle. Our vertex is kind of that. For this one, you can think of it as like a peak. Okay, we refer to this as a maximum. And then this quadratic is facing down, okay, because if we think about it, it's going down towards -infinity as our x's get bigger. Okay, so our quadratics can face different directions depending on the function. So we're going to look at some examples now where we pick out these pieces of information. So if we look at this graph, okay, we want to pull out all of these pieces of information. So we're going to start with the vertex. So our vertex, okay, again, is this peak point right here. Right, so that is going to be at -1 and then -4, okay, and this is a maximum, okay, again, this is going to be that max point that we reach on our graph, okay. Our axis of symmetry, I'm going to do it in the same color red because the vertex and the axis of symmetry go hand in hand, y'all. If you have one, that can help you with the other, all right? So your axis of symmetry, we're going to write it as a vertical line, okay? So like all vertical lines, we write it as x equals, and it's the x value of the vertex, okay? Because it's going through the x value of the vertex. That's what it is by definition doing, okay? So x equals the x value of the vertex will always be how you write the axis of symmetry, okay? For domain and range, okay, domain for every single quadratic, okay, of all time, no matter what the quadratic looks like, okay, the domain is always going to be negative infinity to positive infinity, okay? Last week we talked about, or later this week we'll talk about rational functions and radical functions. Those types of functions have issues with their domain, okay, but we don't have any issues with quadratics, okay? So our domain is all real numbers. Our range, okay, again, think min to max. So our range is going to be up here, up to this point, okay? That is our range. So we're going down forever and ever, okay? But our maximum is going to be at -4. So the way we're going to write our range, think the bottom of our graph to top. Okay, our bottom's going down to negative infinity, okay? Our maximum y value is at -4. Okay, so again, notice that this -4 comes from that y value of my vertex, okay? Your range is always going to include part of, or let me rephrase, your range is always going to include the y value of your vertex, okay? Because that's either going to be your starting point for your range or it's going to be your ending point depending on if you have a max or a min, okay? So anytime you have a max, you're going to go from negative infinity up to that y value of your vertex. All right, let's look at our x-intercepts next. So if we look at this graph, okay, there is something special that happens here. We don't have any point where we cross the x-axis, okay? So for this one, okay, we have none, okay? So you can write none, you could write no x-intercepts. These are going to be imaginary, okay? So these x-intercepts are imaginary, all right? So if we went and we solved this formula right here, okay, where we plugged in a 0 right here as our y value, okay, and then we solve for x, we would get some imaginary value, okay? So we have no x-intercepts because they're imaginary, okay? So just trying to connect that to the earlier lessons when we were solving quadratics and we would end up with imaginary solutions, okay? It would happen when we had a graph that looked like this. Okay, our y-intercept here, y'all, it is not a whole number. So we're just going to take our best guess. Okay, it's going to be this point right here. So we'll say that that is our x value is 0, and then that y value, we'll say it's down about 4.5. Okay. Oops, I did not mean to zoom. My bad. Okay, so that is the characteristics from this graph. Okay, let's look at another example. Okay, so for this one, okay, we're going to go through the same kind of stuff. So our vertex, again, is either that min or that max value. And in this case, we have a minimum, okay? This point is at -2. And then it's up 3, okay? So that is the vertex for this one, okay? This is my axis of symmetry. Okay, so again, going through the x value of my vertex. Okay, so it's going to be at x equals -2. Okay. My domain, remember, domain is always all real numbers. Okay. My range, again, for this one, I told you, it's always going to include the y value of my vertex. And in this case, I'm starting at the y value of my vertex because that's my minimum. Okay. And I'm going from 3 up to infinity. Okay, so that is my range, and again, this 3 is part of that range. Okay, now again, this is a situation where I do not cross that x-axis. Okay, so I don't have any x-intercepts again. Okay, so they are, again, I'll write out imaginary. Okay, my y-intercept for this one, okay, is at 5. So 0, 5 is the coordinate for that y-intercept. Okay, so that is all the characteristics from this graph. All right, so I want you guys to work through, and I want you to find all the characteristics based off this graph. Okay, so take a few seconds and find all of these things. Okay, so the vertex is at 4, 4. Okay, so this point right here is 4, 4. Okay, and that's also the point that our axis of symmetry goes through. Okay, so our axis of symmetry is going to be at x equals 4. Okay. Our domain is always all real numbers, so -infinity to infinity. Okay. Our range in this case, okay, and I just realized I forgot to circle max or min. Okay, here we have a maximum. Okay, that means that our range is going to go from -infinity up to that max. So it's going to be -infinity up to 4. And again, the 4 that it's pulling is that y value of the vertex. Okay. Our x-intercepts, we have 2 of them. All right. So my x-intercepts are here and here on my graph. Okay. So those coordinates are at 2, 0. Okay. And then 6, 0. My y-intercept, okay, is down here, and that is at 0, -12. Okay, so those are my characteristics from this graph. Okay, so we are now going to, this was taking the graph and finding the characteristics from it. We're now kind of going to reverse it, and we're going to be given an equation, and then we're going to use that to graph. Okay, and the way that we graph is going to differ based off the type of equation that we're given. So we can be given an equation in vertex form, okay, which is this form, all right, or I might be given an equation in standard form. Okay, so depending on the form of the equation that I'm giving will kind of depend on how I find the vertex. So for vertex form, it's really easy, okay? So notice my vertex, I write as the coordinate pair h, k, okay? So for vertex form, I just pull out the values h and k from the function itself, okay? So I can just pull it straight from the function, and then I can jump right into graphing. For standard form, I have a little bit of work I have to do. So if we think about standard form of a quadratic, we kind of refer to this when we were doing solving quadratics using the quadratic formula. Okay, we have our a value in front of the x squared. Okay, b is in front of the x, and then our c is our constant. Okay, that's our standard form. The way we find the x value, okay, so this is the x value of the vertex, is we take whatever this value is, -b, over 2 times this value. Okay, so that is how we find the x value of our vertex. And then k, which is the y value of our vertex, okay, we take by just plugging in whatever x value we get for the vertex, we plug it into our function, and then we solve for the y value. Okay, so that's what this is saying. This notation right here is it's saying plug the x value of the vertex into the function to find the y value. So in words, guys, that's what that notation means. I know that that notation can feel a little scary, okay? But what that notation means is just plugging the x value of the vertex into the function, okay, to then give you the y value, all right? So we're going to do some examples of equations in this form first, and then we'll do equations like this, okay? So we have an equation, all right, in vertex form that we need to put, or that we need to graph. So remember, I'm going to go back a slide because I forgot to mention this. This vertex form has a subtraction sign here, okay? So take the opposite value, is what you need to do. So we have to think opposite here. So my vertex is going to be the opposite of positive 3 is a negative 3, okay? And then I'm just going to take the value outside because, again, it's just plus k, so that means whatever that value is outside, we take it as is. But because we have this subtraction here, take opposite, okay, for vertex. All right, so just a little note there for you guys. So the opposite value, again, of positive 3 is negative 3. So I'm going to go over 3, and then I'm going to go down 8, and I'm going to draw my point, okay? My axis of symmetry, I'm going to abbreviate as AOS, okay, is going to be at x equals negative 3. So I'm going to go ahead and draw in this axis of symmetry, okay? And this is going to come in handy. This is actually going to help make my life a lot easier, and you'll see why in a second. So I'm going to start by finding some other points to graph it, all right? So notice I just had found the x value of, or the coordinate at negative 3, negative 8. So my x value was negative 3, okay? So what I always like to do is I like to go and find either the negative 4 or the negative 2. Guys, I'm going to pick negative 2 because it's a smaller number, okay? So you just go like 1 to the left or right of the vertex in terms of the x value. I always go to the smaller number. So I'm going to find negative 2. So if I plug in negative 2 to this equation, okay, I'm going to simplify that. So let me type that in my calculator real quick. You guys type that in your calculator. All right, so when I plug in negative 2, guys, I get negative 6, okay? So let me erase these little arrows. So at negative 2, let me erase that circle, okay? I'm going to go down 6, and I'm going to draw a point, okay? Now, this is where my axis of symmetry comes in really handy. So remember how we talked about everything is reflected, okay? I'm going to just use my axis of symmetry to plot another point. I'm not going to solve it algebraically, but I'm going to do it graphically. So notice this is at the y value negative 6, okay? And it's 1 to the right of my axis of symmetry, okay? So instead of going 1 to the right, I'm going to go 1 to the left, and I'm going to draw a point. And that point got a little big, okay? And that is my new point, okay? So instead of finding f of, which if I did find it, it would give me negative 6, okay? I'm just going to use my axis of symmetry to find it. So instead of doing it algebraically, okay, and typing in my calculator, I'm going to use the graph. Now, I'm a real visual learner, okay? I love using graphs, drawing pictures, etc. So for me, that's really helpful, okay? For some of you, you might just prefer to do it all using your calculator, and that is totally okay, all right? So it's kind of up to you what you prefer. Okay, so that's 2 points. We really don't like to just draw a graph based off 3 points, okay? The vertex and these 2 that we just found. So what we're going to do is we're going to find 2 more points, all right? So I'm going to find, instead of at, we just found negative 2, I'm now going to find negative 1, okay? So I want to find what is my y value at negative 1. So what that looks like, if I plug in negative 1 for x, is this, okay? And same thing, I'm going to type that in my calculator, okay, to find the value, my y value at x is negative 1, okay? And if I plug that in, all right, I get 0. Okay. So at negative 1, I have a y value of 0, okay? Now, notice, I'm going to, again, use that point to help me find one more point. So notice that's 2 to the right, okay? So I'm going to go 2 to the left, okay? And I'm going to plot my next point. So not only did I find f of negative 1, I also found f of negative 5, and it has the same y value of 0. Okay, so that is my function, all right? Now, I'm going to draw the line for the graph through these points to do my little sketch, okay? And that is a sketch of this graph, okay? So it's a bit of a process, okay? But once you do it a few times, it becomes a little bit easier, okay? And again, using that axis of symmetry is really helpful. So I want you guys to try one just like this, okay? So I recommend finding the vertex first, then use that to find the axis of symmetry, okay? Then find two coordinates, all right? And then use the axis of symmetry to find two more coordinates from those, okay? So run through this one, try it out yourself to come up with the graph. Okay, so what I get for the vertex, okay, is 6, -2. So remember, I'm opposite of -6 gives me that +6, and then I just take this value as it is. Gives me the vertex, okay? My axis of symmetry is going to run through the x value of my vertex. So my axis of symmetry is at x = 6. Then I'm going to find some points, okay? So I'm going to go ahead and unhide everything else. Okay, so this is what this one looks like, okay? I had 6 to begin with, all right? So again, I decided to find f of 5 next, okay? And again, that's because I went 1 away from my vertex in terms of x values. And again, I went in the smaller direction. I could have picked 7, but again, 7's bigger than 5, so why would I work with bigger numbers if I don't have to? So I always pick the smaller number. That's just personal preference, okay? You could have found f of 7, okay? So when I plugged in 5, I got -4, okay? And because that was 1 to the left, I then went 1 to the right and down 4, and I got my second coordinate there in blue, okay? I then did kind of the same process. Instead of going 1 to the left of the vertex, I went 2 to the left of the vertex at the x value 4. Okay, I plugged 4 into my equation. I got -10 for the y value. So then at the same time, I went 2 to the right at f of 8. Okay, and I got -10 for that second coordinate. All right, so that is the graph of this one. So that is graphing quadratic in vertex form. Let's now talk about graphing something in standard form, okay? So remember, with standard form, okay, my vertex, we have to find kind of in steps, okay? So step 1 is to take h, which is going to be -b over 2a, okay? Now remember, b is 6, c is 1, and then we can put a 1 there, okay? So we get -1 for a. So I'm going to put -6 over 2 times -1, okay? And then I'm going to simplify this. So when I simplify, okay, I'm going to do it in stages. So -6 over -2, okay? A negative divided by a negative gives me a positive. 6 divided by 2 is 3. Oops, and that was supposed to be an equal sign, not a negative sign. Okay, so I get 3 for the x value of my vertex. So that's step 1, okay? So honestly, from there, I can find the axis of symmetry. X = 3. So I could go ahead and draw that axis of symmetry in if I wanted to. Okay. Now I can find the y value. Okay. So the way I'm going to find the y value is I'm going to plug 3 into my function. So negative, and instead of x, I'm putting 3. Okay. Plus 6 times 3 plus 1, okay, and I'm going to simplify that. Let me move this axis of symmetry down. Okay, so if I simplify that, okay, and let me use my calculator really quick. So we have a -3 squared plus 6 times 3, okay, plus 1. So that is going to give us +10. So my vertex is going to be at 3, 10. Okay. And I'm going to move this all. I did not get everything that I needed to. Down just a little bit. All right. So the vertex that I now can plot, all right, is at 3, 10. So that is going to be this point right here. Okay. So for this one, okay? We have found the axis of symmetry, okay? We have found the vertex. I'm going to grab this, and I have another slide, and we're going to find additional points, okay? So that was at 310, so it should be about here, okay? Yeah, okay. So now I'm going to, again, I'm going to go in the smaller direction, so I'm going to find f of 2, okay? So when I plug in 2 here, I get negative 2 squared plus 6 times 2 plus 1. Oh. Okay, and I'm going to find my y value, okay, and when I plug it in my calculator, I get 9. So 2, 9 is going to be my next coordinate, okay, and then again, that can help me find my next one. So instead of 2, I'm going to go to the right 1 from my axis, okay, and I'm going to plot my point here. So f of 4, okay, also equals 9. All right. And then I'm going to find another coordinate. So I'm going to find it at x is 1. So when I plug in 1 for x, it looks like this. Okay. And then I'm going to simplify that. So if I type that in my calculator, I get 6. Okay. So at 1, 6, I have another point. Okay. And then again, same thing. That was 2 to the left, so I'm going to go 1, 2 to the right at that same y value and draw my coordinate. So that's at f of 5. And same y value of 6. Okay, so those are my coordinates, and I can now sketch my graph. So my graph is going to look, oh goodness, okay. Let me turn my iPad. Okay. Again, rough estimate, okay. I got a little squiggly there, you know, it happens, all right? Just rough estimate of what it looks like. When you do it in Alex, it'll be nice and perfect, okay? So that is finding points given an equation in standard form. So we're going to do one more together, and then you guys are going to try one on your own. So same process for the vertex, okay? For h, I want negative b over 2a. So again, remember, a is the number in front of x squared, b is the number in front of x, and then c is that constant. So here we have a negative b. Okay, remember that b includes the sign, so it includes that negative in front of the 12. Okay, all over 2 times a. So a double negative on top is going to simplify to a positive 12 over 6, which simplifies to 2. Okay, my k, we're going to plug in 2. Okay, so remember 2 is the x value of my vertex. I'm going to plug that into my equation. Okay, and then I'm going to simplify. So I'm going to grab my calculator here. I've got 3 times 2 squared, okay, minus 12 times 2 plus 6, okay. And so when I simplify that down, I get negative 6 for my y value. Okay, so if I plot that, I go to the right 2, I go down 6, and I've got my coordinate. My axis of symmetry is going to be a vertical line through 2. So that'll look something like this. Okay. All right, so I'm going to copy this and move it to the next slide, and we'll find our additional points for our graph from here. And it was at 2, negative 6, so it should be right there. Okay. So again, same idea, same process. Okay, I'm going to go 1 to the left or right of my vertex, and again, I'm going for the smaller number, so I'm going to find f of 1. Okay, so if I plug in 1 for x, that'll look something like this. Okay, if I simplify that, I get y is equal to negative 3. Okay, so that's going to be right here. Okay, again, 1 to the left, I'm going to go 1 to the right at that same y value is going to be my next point. So f of 3 is going to equal negative 3. Okay, so that's the next coordinate I can grab. Okay, And then I'm going to repeat the process. So my next x value I'm going to pull is the x value of 0. Okay, so I'm going to actually find the y-intercept for this one. Okay, now guys, finding the y-intercept is pretty easy for a lot of these. Okay, because remember, anything times 0 is just 0. Okay, so this simplifies to 0. This simplifies to 0. 0 plus 0 is 0. Plus 6 is 6. Okay, so this coordinate's all the way up here. All right. So when you guys are doing functions like this, finding the y-intercept is also always a great option. Okay, now sometimes, like here, you also could have found it. Okay, you would have gotten 1, which we kind of almost went through. Sometimes though, it will be totally off the graph, so that's why it's not always the best case to just jump straight to that. Okay, so to find our last point, instead of 2 to the left, we're going 2 to the right, so that's going to be right here. Okay, so that's at f of 4, y value of 6. All right, so I'm going to draw in my function. And it looks something like that. Okay, so that is this one graphed out. Now, I want you to try this one on your own. So find the vertex, okay, find the axis of symmetry, and then find additional points. All right, so go ahead and attempt this one. All right, so for the vertex and the axis of symmetry, okay, when you plugged in here, A was 2, B was 4, okay, so you had -4 over 2 times 2, okay, which simplified down to -1. So our vertex was at -1, and then when you plugged in -1 to your function, you got a y value of -9. So that was our vertex, all right, which we see plotted over here. Our axis of symmetry is at x equals -1, okay? So if we go to the next slide, all right, this has the additional points on it. So my additional points that I chose to find were the y-intercept, okay? Because again, I went from my axis of symmetry and I went to the smaller numbers, so that meant going to 0 and then 1, okay? So I plugged in x is 0. When I did that, I got -7 for the y value, okay? That was 1 to the right. I then went 1 to the left to find the blue, okay? And then I plugged in f of 1, okay? So plugged in 1 for x. When I did that, it gave me -1 for the y value, okay? So that was 2 to the right. So then I went 2 to the left and got that green point, okay, which is going to be at -3, -1, okay? And that is this one graphed. Okay, so again, just to recap, y'all could have found like f of 6, okay, but if you did that, you would have got a really high y value and it would have been off the graph. At least this one is like a 10 by 10 grid. The same thing will happen in Alex when you're doing your homework, okay? Just make sure, again, you're picking the points just to the left and right of the vertex, because otherwise the chances of being off the graph are really high, okay? Because I think the Alex homework is a 12 by 12 grid. Okay, so most of these you want to pick points, again, just to the left and right of the vertex rather than the ones out here. But if you had a bigger graph, okay, by all means, you could have plugged in, 5 for x and found the y value, okay? All right, let me know if you guys have any questions